Hello everyone, this is Binsu. Welcome to my YouTube channel. So in today's session, we are going to see how to apply step-bar analysis or how to solve a step-bar analysis problem in Ansys Workbench. So I will show you the problem that I'm having. Okay, so this is the step-bar problem that we have. So what you can observe here, we are having two materials. So two different materials we are having here, and the Young's modulus of that material is given. All the different parameters relevant to this drawing is given to us. If we see the boundary conditions, one side is fixed, so this is basically our fixed side. Okay, so I will say this as fixed, and on this side we're applying the load. So let us see how to solve it in Workbench. So what you have to do is you have to open Workbench. In Workbench we have to open the static structural cell. The first thing is we have to give the engineering data as it has been given to us. So right click on engineering data, go to edit. I'm going to write here new materials. So I will write here M1, M3. Now you may wonder why I've given this name. It's basically relevant to this because E1 equal to E3, that is for the first bar, and the third bar, the material properties are same. Okay, so keeping that in view, I have given the name for the materials as M1, M3. Now in toolbox, you have to expand the linear elastic tab, and you have to double click on isotropic elasticity. Here I will change the unit system to megapascal. So this one is having, it is 2E5 megapascal, that is 200 into 10 raised to 3 megapascal. Poisson's ratio I am keeping it as 0.3. Second material I am assigning it as M2. I will double click on isotropic elasticity. So for material 2 it is 180 GPa. So I will change this to MPa, and this I will write it as 1.8 E5, and the Poisson's ratio I will write it as 0.3. Okay, so we have created two different materials, and we close this. Now we have to create the geometry. So for geometry, right click on the geometry cell. We have to click on new design modular geometry. So basically we are going to follow the line body approach, and let us see how to use that. Okay, so the design modeler has opened. The very first thing that you should do in design modeler is go to units and set it to millimeters. Why? Because our unit system or whatever is given to us, it's in millimeters. I will now select the XY plane, click on the sketch icon, click on this icon, look at face, and we will sketch. So I'm going to line. So I'm going to sketch 3 line segments. This is my first, then the second, and then we have the third. Now go to dimensions. I have to give dimensions to it. I'm just positioning the dimensions. Okay, so we normally see dimensions in letters, as you can see H1, H2, H3. Now what dimensions do I have to give? So H1, that is L1, that is 200, 500 and 200. Okay, so L1, H1 that will be 200, H2 will be 500, and H3 will be 200. Okay, so it has now, the dimensions or the sketch has zoomed out of the screen. I will just click on this icon here, that is zoom to fit. Click on this blue dot here, it will make it in ISO mode. And now I'll go to modeling, and I'm going to use this. In concept, I will use line from points. Okay, so I will select this point, press Ctrl and select this point. So this is my first line body. Click on generate. So you can see here line 1. Similarly, go to concept, line from points. Same thing you have to do for the second line segment. apply. Now since it has to be independent of the previous body in operation, instead of add material you have to change it to add frozen and generate. Similarly, go to concept, line from points, select these 2 points, apply operation, click on add frozen. So now what you can see, we have got 3 different lines. Now we have to define the cross sections as given to us. So for cross sections you have to go to concept, cross section, rectangular. So the first cross section, if you see, it is 35 by 35. You see here. Second one is a circle. Third one is a rectangle. So now I will go to this design modeler. In B, I will write it as 35, and this is also 35. So first is created. Second cross section is basically a circle. So I will select circular. Here it is given as a radius. We have been given the diameter as 15, so here I will write the radius as 7.5, and that's done. Now I will create the third cross section, that is rectangle. Okay, so these dimensions are, we are having 35 by 20, so this is 35 and this one is 20. So 3 cross sections have been created. Now what we have to do, we have to expand this last tree, that is 3 bodies, 3 parts. And first select the first one. You can see a cross section not been selected. Just click on this not selected. It will be assigned rectangle 1. Same with line body second. This will be assigned as circular. And third one, this will be assigned as rectangle 2. Click on generate. Now what you can see, basically everything is done. But if we need to solve it in Ansys Workbench, now it is showing as 3 parts, right? So it should come under a single part. So select all of this and I will click on form new part. So what will happen, Ansys will take this as a single part with 3 balls. So now it's complete. Now I'll go to file, close the design modeler. And now we will be working on the model cell. Double click on model cell. It may take time to load depending upon the system configuration that you have. So just be patient for a few seconds. So now the earlier 2 steps that we have did, they are also nothing but they are also the pre-processing stage in Ansys. First we defined the material, second we basically created the geometry. Now in model also we are going to do the pre-processing, that is applying the boundary conditions as well as applying the materials to the given components. Okay, so I guess now it has attached. Okay, still loading. Yes, so what you have to do, you have to go to the geometry, expand this in part line body. We have to assign the materials. Okay, so select it, expand the details of line body. Now this you have to change to M1, M3. Okay, this line body, scroll down, this you have to change to M2, and this one will be M1, M2. So we have assigned the materials. Now we need to apply the boundary conditions. So click on static structural, go to environment. First boundary condition is fixed. Click on fixed here. Click on this vertex. Click on apply. Second boundary condition is force. Click on force. Select this point. Apply. And we will define by components. So we will say it's in the x component. What is the value we have? If you see the force, this is 15 kilonewton. So I will write here as 15 E3. and then I'll go to solution, insert deformation, directional deformation. And directional deformation we are defining in x-axis. And now since we also need to see what is the stress, so the for stress you have to click on solution and we have to apply the beam tool. And beam tool, details of beam tool, you can see it is selecting the complete blind body. So select it, select this one, click on apply. So this is for the first line. Again go to solution, beam tool. Now we will be selecting the second element, apply. Again go to solution, beam tool. I will be applying it for the third line body. Select here, click it, apply. So now everything is applied, so I will just click on solve. Now depending upon the conditions that we have assigned, so Ansys is going to solve it. It is going to first mesh it. It has basically created a default mesh, and then as per the boundary conditions that we have assigned, it will solve in the background. And let us see what is the results we are getting. First we will be looking for the deformation that we are getting, and then we'll be looking for the stress that we are getting at each element. So it will take some time to solve it. So let us just wait patiently for a few seconds. Now it has basically solved 85%. Yeah, so it has been solved. So let us check the deformation. So here you go. So what you can see the maximum deformation is 0.2694. If you need the deformation to be noted at individual nodes, you can use the probe here. So go to probe, zoom this. So here you can see, here it is around this much, 0.2964. Then zoom it at this point. Similarly, this node. Finally, at the first node, it will be 0. Why 0? Because it's fixed. Okay, so that's how you can use the probe to get deformations at these nodes. And then in beam tool, you can see what is the stress of each element. So the first line body stress is 12.245. Second beam element, it's coming as 84.949. And third one, it is coming as 21.44. Okay, so once you have solved it, you can basically close the mechanical window, and then basically you have to just solve it, save it as a project file. I'll go to file, save as, just saving it in my desktop. I'll write it as simple 1D bar analysis. So your save project is basically loading. You can see that red symbol here. Yeah, now it has been saved. I hope so this video has been helpful to you in understanding how to do 1D analysis in Ansys Workbench. So thank you for listening to my video. Stay tuned for more such videos.